Good afternoon all, and welcome to the last in our series of Design Timber, all fantastic projects that came into the webinars, the Wood Awards for 2022. As you all come into the room and settle down, I'll just tell you a few things about Timber Development UK. So my name's Tabitha Binding and I'm Head of Education for Timber Development UK. Timber Development UK is the amalgamation of TRADA and the Timber Trade Federation. So we're bringing together the whole supply, design and construction industry. So literally, as I just said, we're connecting the supply chain, we're leading best practice and accelerating to a low carbon future. And what if we are to do that, then we really need to understand timber in all its species and all its products. And then it doesn't go forward. So why I've got that slide and not the one that I'm expecting. I'm going to horribly say that I'm missing a slide. Yeah, I'm definitely missing a slide that introduces all our fantastic speakers, which is a real miss on my behalf. So I hope that's really settled our presenters down, realizing that things do and can go wrong. But I'm delighted to introduce you to Mauro, Hamish, Dr. Francis and Maisie. And with that, I would like to hand over to you, Mauro, and I'm going to stop sharing. If the audience has questions, I would be delighted if you'd put them in the question and answer chat. And when the team have stopped presenting, then we'll put our questions to them. This is your chance to ask the teams those questions. I mean, from a 5,000-year-old piece of black bog oak, amazing. Mauro, the floor is yours.
Yeah. Hello, everybody. Okay, I'm actually moving the. Let Hamish to introduce the project. Hamish is the project manager and really the man behind the table. That without him, nothing would have been. And I think we start with him presenting the material and how everything came to life.
Okay, thanks, Mauro. Good afternoon, everybody. We have, I hope everyone can hear me okay. I have no idea. But we have a very long story to tell, and we're going to try and do it in as visual way as possible. So I'm going to try and talk for as little as possible, but we have a lot of slides. I'm a cabinet maker, have been all my life, and I run a very small cabinet making business with my wife, Nicola, and we are both passionate about the use of native hardwoods. And we actually found it quite difficult to get the more rarer forms of native hardwoods. So we decided to, roots, burrs, ripples, that kind of thing. So we decided to try and process them all ourselves. And the most extreme example of the way we neglect native hardwoods is actually something called black oak or bog oak. I'm actually going to call it bog oak because I'm used to it. But this is our most precious native hardwood. It clearly there's a finite supply buried beneath the peat. It has unique characteristics which make it very highly prized all over the world, and yet we burn it. Next slide, please, Mauro. So I hope that you can all see the slide. 5,000 years ago, climate change, specifically global warming, led to a drastic rise in sea level relative to land level, exactly what's occurring now. And these magnificent ancient high forests. On this slide, the small tree you can see on the right, that is a tree that's growing today. In fact, it's growing on my small holding, and it's a really, really impressive oak tree. And yet it's about 200 to 250 years old. And yet it looks tiny compared to the Jubilee oak, the timber that we've made, the tree that we've made this table from. So 5,000 years ago, this rise in sea level relative to land level killed these trees. They died standing in water. and it was a very volatile climate. So storm bars were thrown up at the coast, and this water became very stagnant, couldn't support organisms that normally break down vegetable matter. So the trees, when they eventually fell, are preserved under anaerobic conditions, no oxygen, just like the Mary Rose, only these are 4,500 years older. And it's called black oak, but it's not actually a species of black oak. The black color derives from the trees were growing in clay, which was very rich in iron, and this iron is soluble in water. So you can imagine this iron-rich water seeped into the oak, had a reaction with the tannin in the oak, and sent it completely black. Farmers then hit them during their routine cultivation, and they phoned me. Next slide, please, Mauro. There is an exhibition which accompanies the table, and I've obviously had to get a lot of my facts right, and I've applied absolutely no science to my work with bog oak at all. I basically just had to get on with it. But thankfully, two wonderful people, Dr. Francis Pryor and Maisie Taylor, have very kindly sort of given me actually their expertise and their credibility, so that we can, and I'm hoping that you can both just tell everybody a little bit about human existence at that time, because the world of an archaeologist is tantalizing, because it just gives you a glimpse of what life must have been like. And I think it's a very important period in human development. So next slide, please, Mauro. And Francis and Maisie, if you'd like to just take over and talk about this slide, please.
Right, well, I'll go first, as I'll try to talk about what life was like around about 5,000 years ago. Now, we're looking at some of the earliest farmers to come to Britain. Farmers arrived in Britain sometime a little bit before 4000 BC or BCE, depending on how you want to say it. And they brought with them a practice of farming which developed originally in the Near East and spread across Europe. It took about 4,000 years to eventually to reach us. And essentially, they marked a more settled way of life. Before the farmers were here, the great forests that you can see in this picture would largely have been occupied by hunters and food gatherers. And they led a slightly more mobile way of life. So they would tend to follow the deer and other animals that they were preying on. And when farming arrived, people tended to move around a bit less. They tended to cut trees down, clear fields. And as you can see here, they are in a clearing in the forest, but it's an ancient forest with these massive tall tree trunks. And quite unlike the woods that we're used to being in today, which are all of them woods that have regrown probably many times. And there are very few areas of what's called primeval woodland, the original oak and woodlands that like the ones you can see here, because they're mainly in upland areas, places in Scotland, that sort of thing. And you don't have the massive oak trees there. So these massive oak trees look completely foreign to us because you simply won't see anything like this growing in Britain today. And the way of life was settled. So those round houses you can see there were quite substantial. The floor area of one of those houses is more or less the same area in square meters, square feet, that the Great Northern Railway were allowing their railway workers, when they built them cottages in Peterborough in the 19th century. So they're not huts, they're proper houses, and family house. So you probably have had grandparents, parents, and 4 children perhaps living in those houses. And they had a central hearth with a fire that was more or less permanently on the go, particularly in winter. They didn't have a chimney. The smoke filtered out through the cone at the top of the roof. The food they ate was, well, there was meat, lamb, beef, pork. They also would have eaten wheat and barley, probably in the form of bread. And at the same time, they would also have caught eels in the streams, fishes, and so on. And if you bear in mind that some of the fishes were quite, unusual species, it would not surprise me to discover that they actually ate caviar, smoked fish liver, and so on. It was far from an impoverished way of life. That's the important point to note. And when we've discovered their bodies, there's very little evidence that people were undernourished and thin. So you've got to stop thinking about these early farmers as somehow being primitive. They were far from it, and they were very intelligent. And I think if we'd met one of them today, provided we could speak the language, you regard them as just another person.
Sorry, have you finished?
Yes, over to you now, Maisie.
Sorry, I was tensely waiting for my cue. Now, I'm quite lucky because everything I want to tell you is, or most of what I want to tell you is actually in that picture. And as far as the timber's concerned, you've got the little round houses, which are little compared to the trees and little compared to the timber the trees produced. So they did not, I'm sure some of you are wondering about this, they did not cut down these trees and endlessly reduce the timber down and down and down and down till they had something the right size for one of these roundhouses. The roundhouses were built from wood they produced to be the right size. So they were already quite good at coppicing and basically finding what they wanted. And if they knew that if they were going to need a huge number of poles for fencing, for wattle work, and for the main timbers, say, of the roof of the roundhouses, they generated them. They coppiced oak and ash particularly, and knew that eventually they would have so many poles of the right size. They didn't wander around hoping they'd find stuff often. They actually generated it, and yet they didn't generate it in the forest. They generated it on the edge of the forest where there was more air and light and more shrubby plants and so on. Which leads us to, well, what did they do with these huge oaks? And there's one site that tells us an awful lot about what they did do, because it's a bit hard to imagine. I mean, you've seen the size of the planks in the table, and that's with all the modern technology. How do you use timber of that size? Well, in the fens near Haddenham, near Ely, there was a site of a Neolithic long barrow, which is a burial chamber for the Neolithic. And it was made out of a tree. And it was made out of a tree similar size to this. And what they actually did is quite extraordinary. They had a tree similar to this, and the diameter was nearly 2 meters. And we don't know how long it was, but the section we had was, I'm not sure, was it 20 meters?
It was 20 meters.
20 meters long. And they used it for a burial chamber in this long barrow. So they did what's called boxed it. I'm sure most of you will know what that is. And they took off tangentially the outer bits of the tree. So they ended up with a vast square timber. And they did this with wedges. They actually drove wedges in, splitting along rays and rings, picking up the strength of the tree and splitting these pieces unbelievably cleanly, because you can see from the table there aren't a lot of knots and twists and goodness knows what. There's nothing to deflect a split. And they were brilliantly good at it. And they used seasoned oak wedges to split fresh oak timber. So they got down to their square section. They split it again the same way, so that they ended up with 4 huge planks from the outside of the tree, so top, bottom, side to side. And then the inner bit, they cut into lengths. They then reassembled the tree, missing its middle and its outer bit, propping the sides up. So you had a huge, great plank as a floor. They propped the sides up with mounded earth, and they put the 4th piece on top, not resting on the timbers, but resting on the earth banks, so that they had that little bit of height. And they used the central bits, they cut them up to divide the inside into chambers for different, I don't know, families, groups, whatever. And they used the rest of it to make a huge facade for the long barrow. And what this tells you is what Hamish is always saying: these trees were special, they were fantastic, they meant something to people. People didn't just sort of say, oh, that's a big tree, that's a lot of firewood. They did special things with them. They didn't use them for building their houses. They built them for things like the burial chamber. There's 1 or 2 have come up and appear to be markers, boundary markers, and things like that. And there are some that have come up in other never domestic sort of circumstances, always something to do with religion and the way people saw the world. So they were very special. I mean, that's special now, but it was special then. And it must have had such a psychological effect on people when they saw those trees going over, tree after tree after tree. Must have undermined their world. You know, it was the end of the world, whatever was happening. Must have been awful for them. And then luckily along came Hamish, dug it all up, did something slightly different to what they might have done with it, and turned it into an amazing table. But I think the people there would approve, because he didn't burn it for firewood, and it wasn't just cut up and, you know, used with no respect. So Hamish would be the champion of the Neolithic. So there you are, Hamish, if you ever...
Thank you very much, Maisie and Francis. Mauro, could we have the next slide, please? Thank you very much for that. So when the trees are basically hit by farmers during routine cultivation, they're extremely fragile when they're exposed to the elements. So they phone me and I have to get to them very quickly. I wrap them, bring them home. I used to live in the Fens, which is why I know about these trees, but I now live in Kent, which is a little awkward. But I wrap them, bring them home on my 3-ton trailer, and I can store them wrapped up in the round for about 6 months, no more than that. And I'm wrapping them to keep the moisture in. And the sawmilling event, because we do this every year, the sawmilling event has become very interesting to students, other makers, sculptors, designers. I think it's probably because we offer them free tea and cake, but it's become quite a large annual event. And we always do that in September. And because the tree has been at Ely Cathedral, it's raised awareness amongst Fenland landowners of the need to try and preserve as much of this as we can while we still can. Because normally the idea is to just leave them and they shatter along their medullary vessels and completely disintegrate, or they burn, which is fine. That's not a criticism. They're busy people and they've got work to do. Next slide, please, Mauro. So this year we had, or 2022, because of the table's influence, we had 60 12-foot lengths. That's very, very unusual. Sometimes I have none at all. And I hope you can see this slide, because this this represents about a third of what we had this year. And to be honest, I can't help myself. If a landowner tells me that he's found a black oak or a bog oak, I'm like the surfer waiting for the perfect wave. It's like a tantalizing possibility of black treasure, really. And this 2022 haul, I think, is of national significance. And interestingly, they came from the same fen as the Jubilee oak. And there was one there, because the section that we've got is only a small section of the tree. And I'm quite convinced that one of these lengths that was broken up was actually a part of the Jubilee oak. And I've shown some people some photographs with my chainsaw sitting, and I've said, this is the biggest I've ever seen in terms of diameter. And they said, well, it's not going to look that big, but what they don't realize is there's actually a 5-foot bar on the chainsaw. So I'm pretty convinced that may have been, and I know where these are. These really spectacular forests, I know whereabouts they are within the fens. And if the Jubilee oak was going to come from anywhere, it would always have come from this kind of area. And in actual fact, the landowner about 50 years ago who owned this land buried a lot of these trees, and they've just recently been discovered. And although we've lost quite a lot, I just love the fact that he buried them, because we didn't really know how to process the timber. He realized they were exceptional examples, so buried them, I would like to think, for the future generations, in the idea that we might be able to preserve them. And that's exactly what's happened. And not only do we know how to preserve them, we know what they can be used for. Next slide, please, Mauro. So immediately that they're planked, we grade them, and the very best we put straight in the kilns. And the reason I do that is air drying is too aggressive. And I know that will surprise a lot of people, but the basic, I'm not going to, this is kind of the difficult bit, really. The reason that there are very few of us processing bog oak is because it's actually really, really difficult to stabilize them. And we have to put them straight in the kilns. Normally, when you dry native timbers, you work on a localized variation in moisture content of about 9%. With bog oak, it's 3%. Now, that is really, really difficult to do. And in fact, in actual fact, can we have the next slide, please, Mauro? Having just said that we don't ever air dry it, I'm now showing you a slide of an air drying stack. But I'm not air drying them here. I'm just trying to stabilize them. I can't leave them in the round forever because they shatter along their medullary vessels and become absolutely useless. Or they get, if I leave them wrapped, they get a very invasive fungal disease. So in other words, you can dry it too slowly and too quickly. So what I'm trying to do here is just stabilize them. And this is why we always convert them in September, so that the initial months they're exposed to the elements, I can spray them twice a day. When it becomes the summer, then I have to wrap them all. And then I can start spraying them again. But it's just, and when I eventually put these in the kiln, I have to absolutely soak them. And that's actually quite difficult to do. You spray them with water and it just sits on the surface, because the outer faces, the exposed faces, obviously release their moisture. The vessels collapse and it locks that moisture in. But I've got to even out that variation in moisture content. So I have to absolutely soak them in water, turn the kilns up 1 degree Celsius per 24 hours until I reach about 28 degrees. And I leave the dehumidifiers off So this wet, saturated environment sort of encourages the moisture within the boards to move around within it. And when I get this down to about, I can start extracting the water out of the air. Next slide, please, Mauro. This is just an example of black oak. It's a set of 6 tables, 2 consoles, and 2 consoles and 4 squares. But the reason I'm showing you this photograph is, you know, bog oak has many unique characteristics, one of which is this color variation across the width. And the reason that's happened is that iron-rich water, the trees in very, very good conditions. In other words, trees that have been preserved very quickly, covered over very quickly, haven't been exposed to the elements. That iron-rich water hasn't been allowed to penetrate. So it's only penetrated in the outer annular ring edge and occasionally from the shake edge, the center edge of the tree. And yes, so you get this, almost looks like sort of 18th century sand shading. Yeah, the other characteristics of bog oak, because to be honest, we're not interested in this wood because it's thousands of years old. Our customers are, thank goodness, but we're not really. It has much more interesting and valuable characteristics than that. It has, it's a tone wood, so it's used for musical instruments. It has visual impact unlike anything else. If you put a piece of normal oak up against a piece of bog oak, you wouldn't even notice it was there. It has a very large medullary vessel, so when it's quarter sawn, it's spectacularly figured. And it has a density which outweighs all the dalbergias, so all the rosewoods, a lot of the very highly valued tropical hardwoods. You know, bog oak can be heavier. In fact, the bog oaks that I deal with, I try and bring them back when I think they're going to dry to about somewhere between 800 and 1,000 kilos a cubic meter. The heaviest, the most dense I've ever measured was 1,166 kilos a cubic meter. And I know people listening to this will be amazed by that. It's actually heavier than ebony on occasion. So it's a beautifully figured ebony, which is grown in this country. And of course, it's the only native hardwood that's black. Next slide, please, Mauro. This is a photograph of an acoustic guitar, but it's very important as a tone wood. These musicians, it's been led by the interest in this wood as a tone wood. Very, very unusual for a native hardwood. Has actually been led by the musicians themselves. They're even more obsessed with it than me. And it's used in percussion, woodwind, and stringed instruments. So violins, acoustic guitars, violas, cellos. Next slide, please. This is a photograph of Bentley Motors contacted me and wanted an interior of bog oak for their centenary concept car. And I said, fine, I've got it, you can have it, but you must not offer this as an option for cars in the future, because I cannot sort of guarantee that I'll have it. And they said, no, that's absolutely fine. And I said, well, if you don't mind, could you just put it to me in writing that I told you that? And I'm really glad I did. Next slide, please, Mauro. So this is a picture of the Jubilee oak. What you have to understand is normally these trees are broken up. They all look the same. They just look like gigantic lumps of mud. They don't look like trees. And they all weigh the same because they're at absolute fiber saturation. So when they're lifted up or when I cut them, water pours out of them. But this tree was staggering, took my breath away because it was complete. When I first see these trees, I have to try and get an understanding of the condition that it's in. And the only way I know how to do that is to chip away at it with a hand axe and get an idea of the resistance and density of it. Because what happens is, if you imagine these trees very densely growing together, when they fell, they would have fallen on top of their canopies, fallen on top of one another. So any areas of that tree that are exposed gets very invasive fungal disease and insect infestation. And I call it pockets of rot. And it usually breaks on those pockets of rot when it fell, or it breaks when the farmers take them off the field. This is after I've cleaned it, spent a long time cleaning it, and I couldn't believe the level of preservation. This is actually, you can't really see it in the photograph, but it's got bark on it. I've never seen that before. And I chipped away, and I said to the chap I was with, I can't believe this. There's not a single insect flight hole. no pockets of rot at all. And anyway, we marked it out to 12 foot long, just about to cut it, filling up the chainsaws full of fuel. And the land manager said, so which way up was this? Which is the canopy end and which is the root ball end? And we stopped and we looked at it, and then the penny dropped. And we realized that, staggering though this branchless length was, it can only be a small section, the top section, as it turns out, of a much, much larger tree. And I said, okay, Bob, we're not going to cut this. We're going to retain it full length. We turned it over, had a look at the other side, and then reburied it while we tried to work out what on earth we were going to do with it. And he said, this is the stupidest idea that you have ever had. But you see, it gave us a creative opportunity to try and give a unique insight into the scale of these ancient high forests. I've always wanted to do it, and this was the one. Next slide, please, Mauro. So I had my brow severely beaten all the way home, telling me what an idiot I was to retain this full length, because I just thought, naively, I'd make a table, but it actually turned out to be a 10-year, quite an expensive project. Anyway, I got it home, and to the horror of Nicola, came back empty, and but phoned up this company in Canada who manufactured sawmills, whose tagline happened to be, we can plank any length. So I phoned them and said, oh, we've got this Fenland Black Oak, it's 5,000 years old. It's absolutely amazing. And I was speaking to their UK agent. She then said to me, well, I'll phone head office and see what they say. And I thought, well, that's the last I'll hear of that. She phoned back within half an hour and said, yep, fly you over, brand new machine, all the extension beds you need, all the blades you need. If we can just have the photographs. Those telehandlers, again, were donated, not given to us, obviously, loaned for the day for free, because it's actually quite difficult to lift it. Bog oaks, when they're wet, are very fragile. Next slide, please, Mauro. So this is one of the students and staff at the Buildings Crafts College helping us move these planks. We wanted to involve the students for two reasons, really. One was obviously we needed a lot of people to help us move them, but also we wanted to try and encourage the next generation of craftspeople in a kind of real world project. Next slide, please, Mauro. So this photograph gives you an idea of the size of these boards. We went from an isolated field in the Fens to closing a road in one of the most urban environments in the country in order to load them in the kiln. So it took 18 people to load the kiln when it was wet, and we unloaded it with 5 of us. Next slide, please, Mauro. This shows the kiln. I mean, there could potentially be a great deal to say about this, which is probably a bit dull to most people, so I won't. But we had 3 dehumidifiers, 11 additional fans. The people who know about timber will know those stickers are ridiculously wide. But the problem is bog oak is very soft when it's wet, and we had to apply about 2.5 tons of dead weight on top in order to try and keep them flat. But we extracted from this tree, and this is quite normal with bog oak. We extracted, well, it took us 9 months to extract 4 gallons of water per cubic foot. That's 2/3 of its sawn volume in water. Yeah, so that's 397 gallons, 1.6 tons of water. They shrunk by half their thickness, 1/3 of their width, 150 mil in their length. So they really did shrink half their thickness. So, and the issue with that is that, so you may think, well, just cut them thicker. The problem is that you get what I call an accumulated vessel collapse. So the thicker you cut it, the more at risk you are of losing the whole lot. But we cut it at 69 mil after much sort of soul searching and trying to work out, because of course, you know, if you've got to allow a board to shrink half its thickness and stay flat, it's difficult to do that over a meter, you know, let alone 13 meters. But yeah, so, and also you can dry it too slowly. So you can get a very invasive fungal disease, which is particularly obvious at the stickers, and it seems to generate, this fungal disease seems to generate within the board itself. And so you're not aware it's there until you see it on the outside, and then it's very deep and much too late. Next slide, please, Mauro. So this is after they were dried. Yes, as I say, it took 5 of us to unload it, which was a bit of a relief. But obviously we had to try and assess whether we'd actually been successful. It's very difficult with a dry board to assess what kind of thickness you're going to eventually get out of it. So we built this ladder. What we used to, at Advances, we used to call this a straddle. So there's a datum every 600 mil. And whenever we worked on these boards, we always had to keep them in their resting state. And I've got some long reach digital calipers, so we could measure the boards anywhere throughout their width to see what thickness it was. And don't forget, they shrunk by about almost half their width as well. And also these boards became incredibly valuable. We found out we could actually use 8 of these boards, having tested them, and get a decent sort of 30 mil thickness out of it, because we didn't want a really chunky, rustic tabletop. You know, we knew that, well, we hoped that it would go into quite important, elegant public spaces. So we wanted it to be quite thin. And also we wanted it to be quite light, you know, because a board 13 meters long is seriously, you know, heavy. So they became very valuable. So we decided to set up a trust. We had to set up a trust, partly to ensure that we used it appropriately, but also to set up a design team. And what was beautiful about this was actually laying them side by side, and everybody, they're very beautiful laid side by side, staggeringly straight, weirdly straight actually, and even the gaps between them are quite beautiful. And also it tells you so much about the tree by leaving them as far as we can in their natural state. Tells you a lot about the tree. For example, they're the same width each board, and they're quarter sawn. So that must tell you there's no visible growing taper there. Next slide, please, Mauro. So this was my attempt at what we call the river joint now. Rivers obviously feature very heavily in the fens. And when you try and join these boards together, I mean, we join boards together in its width all the time, you know, but it's quite unusual to see them in a kind of a wobbly joint like this. But again, it was a way of retaining retaining information about the tree, really. But this was my first attempt, which was very much frowned upon. So the too much about you, Hamish, you're showing off. We want to see, you know, you've got to let the tree dictate far more than we're not interested in what you can do. So we established a design team, and but obviously you've got to actually, and it's very unusual for a team of independent designer makers to work together in this way. And of course you can't pontificate and prevaricate forever. You've actually got to make decisions about things. So we needed a design leader or a lead designer, and that was Mauro. So next slide, please, Mauro, and it's over to you.
Thank you, Hamish. So yeah, we met the first time in 2012 at the Building Craft College. It was the time when the project started, and I was a maker in residence there, and I was really excited about all the learning you transferred to the college about the bog oak the previous year, and knowing that you found this amazing log. It was a unique opportunity to kind of to consider what to make with it. Making a table was not the first. I mean, it came to be the best option for the wood to be used, but it could have been anything, to be honest. The table has been chosen because it would have given the possibility for the wood to be appreciated at the right height, to be touched, and not just to be an object to be displayed in a museum. A table can be used is the moment where you sit down and you interact between people. So it's got many meanings. This is a set of the first some of the first sketches we made. Since the beginning we had this idea of having the board suspended in the space to leave the wood as the prime subject of the scene. And to do that, we thought, okay, we need to design or think about an understructure or a structure that is cantilevered. And we thought about, okay, just having two pedestals can be good. We then moved the thinking forward, and we said, okay, maybe the two pedestals can be also helping the structure to move when it's together. So by placing them in the middle of, halfway in the middle of the structure, when it's divided in two, it can leave the possibility for the part without the top to be relocated easily. This is the first model we made after the sketches. We thought it was quite convincing. You can see the two pedestals, this kind of slim understructure, optimistic at that time, but it was made out of three long spines. The pedestals were separated from the top to alight, to leave the tabletop by itself, so it was more look like it was suspended. And at that time we thought, okay, maybe we leave the boards separated one from the other, so you can clearly see the length of them and the shape of the trees. Must be said that this is just a concept, so the table would have not been so usable possibly, and we didn't know at that time what the boards were looking like, would have looked like after being dried. So there was many unknown territory to investigate. This is the sorry. This is the presentation drawing that we shown to venues around UK, because we were looking to have a place where to place the table. It is when we, not until when we spoken with, we got in contact with, sorry, with Ely Cathedral, that we, sorry, I apologize. Sorry. That we've been able to define better the brief. This is the Lady Chapel at Ely Cathedral. When we saw this space, we thought it would have been really amazing to be able to place the table there. During the conversation with the cathedral, we actually moved forward the design and develop it to what it is today. At the bottom, at the top, you can see faded the original concept, and you can see how it's improved with the final design. One issue that we had to face, and we knew it was the issue that would have been faced also in other venues. It was to deal with the weight of the table pressing on the floor. The cathedral and also other venues of that type, and basically this table is going to be housed just of in this type of buildings as fragile floors. So the weight is an issue. What we did, instead of changing completely the design of the understructure and the number of legs, we just doubled the pedestals, so to increase the area where the table is sitting. One thing that we kept from the previous design is also the fact that the pedestal is not touching the underside of the top. And one thing that we improved drastically is the number of spines that support the table. Through the dialogue with the structural engineer, we've been able to reduce the number of the spine to one, and with some ribs attached to it. And this is also when we introduced the river joints, which is a spectacular detail because we can still see the full length of the boards, the shape of the tree, and is also a reminder for the place where it comes from, because it looks like the canals that you can find in the Fenlands. Another aspect that we introduced at this point was the material. The understructure is now designed all in bronze, which was a material that we thought was very sympathetic with the age of the tree, being the Bronze Age, dated roughly 3000 BC. This is another detail that we introduced. Because the table is so vast, we've been asked to mitigate the width of it, and we did that by introducing some hinges so the two outer boards can fall down. The mechanism works in 3 steps. So you basically have a sliding hinge that you pull out. you take the board, you pull it out by a couple of centimeters, that release some resting arms that are connected to the ribs. You rotate back the arms, and then you are able to fall down the board. In this position, the table is just 900 millimeter wide, or less than 100 millimeter wide. You can move it on the side of a space if the space needs to be used for other type of events. It can be used as a display table, and it can also pass through doors. This is a drawing showing the complexity on in the design of the pedestals. They have each pedestal has 3 set of double castors. They are made of this special rubber that is very gentle with fragile floors. In the pedestal, there are also some adjustable feet to expose the feet and the castors and the wheels. So you slide up the cladding that is surrounding the pedestals. The feet are not there for leveling the table because of its weight, and on the fact that there are just 2 supporting points level by itself. The feet are there for locking the table in position when it is unlocked, and when the cladding is up, the table can be wheeled around easily by 2 people. Is incredible actually how it moves. And it can also ramp up some ramps. This is a drawing showing a CAD drawing showing all the parts that are actually forming the understructure and the table. It shows also the different technologies that we used. I mean, this is generated by, of course, using computer-aided design. All the parts in metal have been cut with a water jet cutter, precisely designed. Some of them are CNC milled. The project is spectacular because it put together really today technology with the known material and also traditional technologies to make it. It is actually remarkable to say that everything has been designed to the precision of a millimeter or less than a millimeter, but then checked before manufacturing or on site using just a string line. These are some of the parts that manufactured by Benson and Sedgwick. On the right-hand side, we can see all the ribs. You can see they are all different lengths. They follow basically the edge of the boards, and they try to get to as close as they can to the edge, so they can restrain the movements, the natural movements of the wood. On the left-hand side, we can see the 2 parts of the central spine, and this is the understructure that is assembled and in the process to be patinated. On the left-hand side, we can see the yellow string line that actually we used to check that it was within tolerances requested to the manufacturer. And this is when we started actually the fabrication of the tabletop. And can go back, Hamish.
Okay, thanks very much, Mauro. the amazing thing about that is that we all actually got on with one another. No one's fallen out with each other. We had a brilliant structural engineer, structure workshop, Peter Laidler, who's a bit of a genius. But yeah, no, we've all, and we've made so many sort of friends through this. But it is very unusual for so many designers to work together, and that's all to your credit, Mauro, really. This is the joinery workshop at the BCC during normal life. Next slide, please, Mauro. And this should show you what we did to it. We basically had a planer that was supplied by SCM, who very generously shipped that over from Italy. And Mauro designed these extension beds either side. Yeah, that planer is about 100 foot long, including the extension beds. And obviously they had to sort of travel up and down with the planer. And I'm not going to go on for too long about this, but basically we had to establish a kind of hit and miss datum. So, and we did this by turning one of the extension beds into a chalk bed. So we were able to agitate the board on the chalk bed again in its resting state, and then we could see the high points. We just relieve those high points. But what you don't understand is, because obviously one's not used to using 13-meter boards, is it's actually quite, because they're so heavy and so long, you can actually manipulate the boards under their own weight. So you have to relieve the high spots in tiny amounts to make a really big difference to how much the sort of raised up areas are. It's a difficult thing to explain, but yeah, anyway. And so then what we actually did was we made a sliding sledge. So the board doesn't actually move on its own. We set the board up. Once we'd established this hit and miss datum, we set the board up on a sledge using wedges and packing pieces, and just glued using them using hot melt glue. One thing to remember, if you ever get to plane up a 13-meter board, always remember to make sure your extractor sacks are empty, because you'll fill one up with just one pass. We found that out to our cost. Next, you just end up with a big explosion of black dust. Next slide, please, Mauro. Actually, before we started planing it, we had to stabilize each plank. I mean, the planks were breathtakingly beautiful and very rare, but they did contain defects. And normally you would do this with what's called a dovetail cleat, but we felt, or the designers felt, that in this instance that was a little bit brutal. So we designed this system of using these laminated wave-like components. And there's several reasons for doing that. They're actually immensely strong because the grain's following the direction of the component, but they're also quite flexible, which is a good thing in this application. And we were able to just inlay them from the underside. It also meant that the students were happy to set them in, because we were routing off a jig. When boards are this rare and this valuable, it's actually quite easy to be a bit frightened of them and not want to actually touch them. Next slide, please, Mauro. We called those stitches, and I don't think it had been done before. You can see them on the underside. They're quite interesting. This I think this slide should show, I can't actually see it, but I think it should show the river joints and how we built the river joints. You've got to remember, these joints aren't glued. And obviously rivers feature very heavily in the Fens. And anyone who's seen this table will see that because they're detailed with a little V, the light glints off, and it does actually look like rivers. And they are incredibly accurate, because if you're going to do this, something unique like this, you've got to do it well. And I get told off a lot for saying this, but actually it's incredibly easy. It's one of those very rare situations where something looks much more difficult than it actually is. Although it has been pointed out to me that it's only easy because we actually know how to do it. It did take quite a lot of experiments to try and work that out. But you'll see on that tracing, there is a red line. Well, the whole thing, this entire table was made using just one technique, basically, and that was a string line. String lines over 13 meters, a very tight nylon line. You can see if your datum is out by 1/10 of a mil. It's incredibly accurate. Next slide, please, Mauro. Clamps. When you glue something up, clamps can cover up a multitude of sins. When you're not gluing it, the joint just has to be as good as it looks. When we did this, because we're not gluing them, we used tongues to join them together to keep them at the same sort of level in case they move. We started off using square tongues like you would normally, not really sort of thinking about it, but they become quite tight, you know, and over 13 meters, we literally couldn't pull these boards apart. Even though they were quite accurately machined, we couldn't pull them apart. So the brilliant structural engineer and the fantastic tooling sponsor, Wilden Tools, came up with this solution of a tapered tongue. And this is genius, again, because it's just so simple. And it's used a lot in masonry, I think. But the joint is really tight right at the last minute. But as soon as you start pulling apart, it becomes really loose. That was just a brilliant solution to this. And the owner, Alan, phoned me because I think he had these cutters made in Taiwan. And he phoned me and said, right, your cutters have been delivered, Hamish. They're the only ones in the world, so I'm not sending to them. You are sending them to you. You've got to come and collect them. Next slide, please, Mauro. This should be a slide. Yes, that's a slide of the making team. It took us 3 weeks. We had the Building Crafts College for 3 weeks. Next slide, please, Mauro. So this is the team that helped us make it. This is the table being delivered at the Isle of Ely College. Ely Cathedral. The reason that we wanted to put it in Ely is because Ely sits high on an island surrounded by the fens. You know, these jet black fields which occasionally yield bog oaks. And the haulage company who are sponsors, this is the largest articulated lorry you can have on the road without an escort, and the boards just fit in. So a huge thank you to Malco Freight, who have literally transported these boards all over the country. Next slide, please, Mauro. This is a picture of the understructure coming off the lorry, and it comes apart in 2 sets. In fact, the whole thing comes apart, but Mauro's designed it so that the understructure can come apart in 2 sections in case the table needs to be moved quickly somewhere, because you know the amount of labor involved in moving the table is significant. So this understructure, when it's put on the ground, is wheeled like a wheelbarrow. It's really amazing to see it, and by just 2 people, silently. Next slide, please, Mauro. This is the boards coming into Ely Cathedral, and that little door on the right of the picture there, that's the wicket door on the west door of Ely Cathedral. The whole thing, excuse me, came through this little wicket door. Next slide, please, Mauro. This should be the table under the octagon, and this was actually the first time that we'd been able to get far enough away from this table to actually see what we'd made. And when the trustees said to me, isn't it fantastic that the Dean has allowed us to put the table under the octagon? Because it's a very sacred space. I said, well, is it really? I kept having this terrible recurring nightmare that it just looked like a piece of doll's house furniture. But that, you know, you realise that if you'd seen that, if you're not familiar with the space under the octagon at Ely Cathedral, you'll understand why I was concerned. But it looked absolutely magnificent. Right, sorry, next slide, please. This is another photograph from above. It's a drone shot of the table under the octagon, and you can spin it. 2 people can move this table, and you can just spin it round. We span it just for the hell of it, and it really is amazing to see this table move. But another thing to consider here is that these boards are actually book matched. So whenever you book match 1 board or 2 boards rather, you'll get you get sort of double the difference. You know, if there's some sort of if it's not straight, then that's manifested twice. Well, we've done this 4 times, and yet you look how straight it is, you know, over 13 meters. It really was, well, actually, I think our most significant oak tree. You know, oak is emblematic in this country. And in terms of ancient provenance and size, I think you'd have a job to beat this one, really. I think it is the mother of all native oaks. Next slide, please, Mauro. This should show, yes, this shows the, there's an educational exhibition which accompanies the table. Next slide, please, Mauro. This shows Mauro telling, it's unveiled by Princess Anne, and we've just demonstrated how, I mean, basically, we've created a gigantic drop leaf table. So we were just showing her how we folded a leaf. And there's text carved into each end to commemorate, because it was excavated in 2012. One end commemorates the Diamond Jubilee, and that's sort of officially allowed. And the other end, because it took us, to my shame, 10 years to make, the other end is engraved to commemorate the Platinum Jubilee. Next slide, please, Mauro. This is a few, but by no means all of the people involved. The vision for this table was always for it to go into the Lady Chapel. I actually think it's one of the most beautiful spaces in the country, partly because Henry VIII, bless him, smashed all the stained glass windows, so the glass is all clear, and the quality of the light in the Fens is just beautiful. And against that pale stone, this gigantic black slab, it's just beautiful. Next slide, please, Mauro. Yeah, there's very little I can say about this, really. I think it's
huge thank you, Hamish. I know
right.
we've
gone over.
run out of
Sorry.
time. There might be one more slide you have there.
There's several more, I'm afraid.
I know it's been absolutely fantastic, and so pleased that you've had the time to share it with us, and your enthusiasm, all of you, has so shone through. And I know it is now sited in Rochester, and it's there, I think, until maybe April 2024. So if anybody's down there, I would really encourage you to actually go and see it in person. And Hamish, I want to come and join you in September. I want to come and see you mill one of these black oaks, and I'm sure there's lots of other people out there who would like to do that as well. We have had one question. I think this is probably for Maisie. How old would the tree be when you saw the slide with the black oak on there? How old do you think that would you have any idea?
Well, these really big, really straight trees have to be before the Bronze Age, really, because quite early in the Bronze Age, they ran out of them. They had been cut down, they'd been drowned by the rising water. So if you go out in the field, and so it hasn't actually been dated scientifically, and you're shown something like that, has to be Neolithic. Those trees just didn't continue into the Bronze Age. They're gone.
I mean, can I just say, Tabitha, to answer your question, sorry, yeah, okay, I'll be very quick. It's been dated by dendrochronology to between 4,800 and 5,500 years old.
So, and how long do you think the tree was growing? Yeah.
I think the section we have is about 250 years old.
Right, absolutely, yeah. Amazing. I can't, in a way, get over what what you've actually done and what you've shared with us. Yeah, from the beginning. I'm trying to get my slides up, and it's gone from the beginning. Sorry, there I am getting all back to front and upside down, and I have finally found the slide to thank you all for it. And again, any questions from anybody in the audience, please pop them into us, and we will put you in touch with all the right people. I know you're hidden on, you don't all do social media, so we have looked for you on LinkedIn and other places, and we couldn't find you there. But where you this is the last in our series of 6 from this year's Wood Awards, and we would just so much love to have more time with you. But today it's definitely so not possible. I mean, here is the link to the QR code to where we put all the recordings. And yeah, with that, I just huge thank you. And I just encourage people to come and see it in person.